Good morning, everybody. My name is Debbie Schnorr, and I'm going to present an overview of composting for school and community gardens. And this talk is really for anyone who's wanting to compost at a larger scale. And if you attended my Master Gardener presentations on composting in the last couple of months, this is an abbreviated version. So I'll just give you a little background on me. I completed my Master Gardener training in March of this year, and I'm an environmental education coordinator with the University of California Cooperative Extension, San Bernardino, working with Maggie. And I live in Rancho Cucamonga, where I'm a member of the Route 66 Community Garden. And I've been working on larger scale composting projects at Route 66 for the past year. And I was also a Food Corps AmeriCorps service member at Phelan Elementary School during the 2019-2020 school year. So here are the topics for today's talk. I'm going to start with the basics. What is composting and why compost? And then I'll discuss the main types of composting, focusing on hot composting, composting ingredients and process, how to tell when compost is ready and how to use it, composting tools and systems, some tips for school composting, and then steps to get started. So let's get right into it. What is composting? It's using the natural process of decay and decomposition to convert organic waste into a dark, crumbly, nutrient-rich material called compost. And materials that can be used to make compost include things like grass clippings, food scraps, and leaves. And we're going to get into some more details on what goes into compost in a few slides. So why should you compost? There are so many reasons. First off, it's an inexpensive fertilizer that decreases the need for chemicals. When used as a soil amendment, it improves the soil structure and tilth, which is the ability to support plant growth. It increases the drainage of clay soils and increases water retention of sandy soils. When used as a mulch, it prevents weeds and keeps moisture in the soil. It also keeps organic materials out of landfills, reducing greenhouse gases. When fewer chemicals are used, there's less runoff into water sources. And for schools, composting provides hands-on learning that can be connected to academic standards. And composting also promotes community engagement and empowerment. And I really like this quote from the Institute for Local Self-Reliance about why community composting is so important. And this also applies to school composting. It says, community composting keeps the process and product as local as possible while engaging the community through participation and education. So it's not only about benefiting the planet, it's also about building community. So there are two main types of composting, cold and hot. And unless you have a lot of time on your hands, we recommend the hot composting method. Passive or cold composting is basically set it and forget it. You build the compost pile and just leave it there for a year or more. And with little management of the pile, the materials will decompose very slowly, but they will decompose. Also, weed seeds and pathogens may not be killed in this process, so that's one of the negatives. Then active or hot composting, also called thermophilic, requires managing the compost pile, the conditions to achieve higher temperatures and optimal conditions. And the temperature should be over 100 degrees. And these high temperatures are more likely to kill weed seeds and disease-producing organisms. So that's a benefit. And also, it's a much shorter time to finish compost, and usually talking about months rather than years. So in hot composting, temperature really matters. Active composting can occur anywhere between about 55 degrees to 155 or 160 degrees. The most rapid decomposition happens between 120 and 140 degrees. And when the pile gets too hot, then the microbes will start to die off and the decomposition slows. So especially when you're getting started, it's a good idea to keep track of these temperatures, and you can use a composting thermometer. If your pile is smoking when you turn it, that's a good sign. You can buy a composting thermometer for about $20 online. And the main feature of it is that it has a long metal stem that can go deep into your compost pile. So the basic ingredients of composting are the organic materials. They're also called feedstocks, water, and air, which contains oxygen, and all living organisms need oxygen. And organic materials refer to anything that was once alive. So by managing the ingredients and the temperature, you can speed up the decomposition by the micro and macroorganisms. So for the organic materials, there's two main types, browns and greens. And the browns are rich in carbon and things like wood chips, sawdust, leaves, straw, dried plant materials, stalks and twigs, shredded newspaper, and cardboard. And the greens are nitrogen-rich materials, such as raw vegetables and fruit scraps, coffee grounds, crushed eggshells, cut flowers, grass clippings, and fresh garden trimmings. And while most of these are green, not all of them are. For example, the coffee grounds and the crushed eggshells, but we call them greens just because they're high in nitrogen. So what are the differences between the browns and the greens in the compost pile? Well, the browns decay more slowly. Coarse browns like wood chips can let air into the compost pile, which is important to keeping the organisms healthy. The browns, such as fallen leaves, tend to accumulate in the fall. Also, browns can tie up nitrogen in the soil if they're not fully composted. So it's important not to use the compost too soon before it's ready. And in the fall and winter, you may have more browns than greens. So you may need to stockpile them and wait to use them until you have those greens. In contrast, the greens will decay rapidly, and eventually they also many of them will turn into browns. Because the greens decay more rapidly and they tend to be less bulky, they can cause odor problems. So they can get kind of wet and slimy. So if you do have problems with that, you can just add more browns. They accumulate more in the spring and summer when garden plants are growing. And as I mentioned previously, they supply nitrogen for composting. And you need to have the right mix between browns and greens to increase the aeration and decrease odor in your pile. So this is a list for beginning and small scale composters of materials to avoid. There are municipal composting operations and farms that use many of these materials, such as meat and animal manure, but it really depends on where you're located and how much of an issue odor problems might be, how much heat you can generate in your pile, how you're handling pest and odor problems. So you can see what works for you. So when you're starting out, you may want to consider avoiding meat and bones, cheese and dairy, oils and grease, and cooked food, animal manure and pet waste. But then as you get more experience, you might want to add some of those things in, so you're composting more of your organic waste. Things that you never want to put in your compost pile are those pesky produce stickers, because they do contain plastics, glossy or coated paper or cardboard, treated or painted wood, anything that's got something with chemicals in it, diseased or poisonous plants, and aggressive weeds and grasses. And a good rule of thumb is to not put anything in your compost pile that you wouldn't want in your garden. So once you've added your greens and browns to your compost pile, you want to create an environment where the decomposers are going to thrive. And there are two main types: microorganisms, also known as microbes, and macroorganisms. And the microorganisms are bacteria and fungi, and those will chemically transform the organic materials, and their activity is going to heat up the compost pile. And then the macroorganisms are things like snails, earthworms, flies, beetles, and they mainly shred the materials into smaller pieces that the microbes can consume. And they will also feed on some of the microbes. Sometimes we consider these macroorganisms pests, but they're actually essential for composting. And once your compost is finished and it cools down, they will generally move to a more hospitable place. So not to worry when you see these things in your pile. So turning is one way to create an optimal environment for the decomposers. Turning the pile on a regular basis exposes all the materials to oxygen. It'll release trapped heat, and this is especially important this summer if the pile is getting too hot. It'll distribute the water and the nutrients and the organisms and break up the bigger pieces of materials. And generally, the more often you turn the pile, the faster it will decompose. And the most important time to give it attention is when it's warming up. But if you get busy and you don't have time to turn the pile, it's okay, because that'll just increase the time to finish compost. The best way I've found to turn the pile is with a pitchfork, especially the 5-tined pitchfork shown here. It's sometimes called a manure fork. It seems to have just the right amount of tines to be able to carry a good amount of material. If you have a big pile, a pitchfork works much better than a shovel. So as I mentioned before, water is one of the key ingredients in compost. And for fastest decomposition, the water content needs to be just right. So if the pile's too dry, decomposition will slow down or stop. If the pile's too wet, the process may go anaerobic. That means it's lacking in oxygen, and the pile will start to smell. So again, just add more browns to the process. The water content's ideal when it's about 40 to 65%. You don't have to measure it, just use the hand test. So take some compost in your hand and squeeze it, and it should feel like a wrung out sponge. Maybe a few drops of water will come out. So other factors to consider are the size of the input materials, the balance of browns and greens, and the size of the pile. So the smaller the materials are that you put into the pile, the faster they'll decompose. So it's best to chop the materials into 1.5 to 1.5 inch pieces if you can. You can also shred or grind woody material and leaves, as long as you're keeping it bulky enough to maintain the aeration. And then for the balance of browns and greens, the optimal carbon to nitrogen ratio by dry weight is 30:1, and different materials have different ratios. You can look these up online. and then try to figure out how much of each material to put in. But it's also easy to estimate this ratio just using equal volumes of browns and greens. So again, if the pile is not getting enough air and it's starting to smell, then you add more browns. If it looks like it's really not heating up, then you can add more greens. So you can experiment with that. I tend to err on the side of too much browns. And then for the size of the pile, also you want to use your coarse browns as a base and a cover layer. So if you look at the picture on the top right, you use a base of, say, wood chips on the bottom, and that kind of catches all the liquid and keeps it from seeping out. And then you want a cover of browns over the top so that it covers all the food scraps and you're not attracting a lot of pests. And there's also a minimum size for the pile for best hot composting. And that would be at least 3 feet tall by 3 feet wide by 3 feet deep. So that's 27 cubic feet. So that just gives you enough material to attract the microbes to really get it hot and then keep the heat inside. So in hot composting, the pile goes through several temperature phases. The first is the mesophilic phase, where the temperature ranges from about 50 to a little over 100 degrees. And that over the first few days, the pile will start to warm as the bacteria and the fungi grow. And then the key phase, where most of the work is done, is the thermophilic phase. And then the temperature will go from 105 to as high as 160 degrees. And the pile reaches its peak temperature as the microorganisms break down the organic materials. And this can take anywhere from days to months, most likely weeks. And it really depends on if you continue to add more of your organic material, or you just put all the organic material in at the beginning and then just let it go. So if you want to finish composting, eventually you stop adding that organic material and you just let it cure. And so the final phase is curing, where the pile cools down and the decomposition will slow down and eventually stop. So when the pile no longer heats up after turning and you've stopped adding more material, let your pile cure for at least a month. I would say 2 to 3 months or more is better, because then you'll just get a finer compost. And you want to make sure that the active decomposition has finished. And again, the longer you let it cure, the finer and more soil-like that compost will be. And while the pile is curing, keep it moist and aerated, but you don't have to fully turn it or give it as much attention as you do when it's heating up. So how do you tell when the compost is ready? Really just looking at it and smelling it. When it becomes dark brown and crumbly, it smells earthy. It may not be as fine as what you see in the photos, but you shouldn't see any big pieces in it like banana peels, apple cores. Those should already be broken down. And then the pile will shrink significantly to about 1/3 of its original size. And it's really amazing that you could put hundreds of pounds of food waste into a pile and you end up with something that's really, really small. But that's part of the beauty of it. And so you can also do some simple tests to see if your compost is ready. The first is the bag test. So you're going to seal moist compost into a Ziploc bag for a couple of days. And then when you open it up, it should still smell good and earthy. And the second test is a germination test. So plant some seeds in your compost and see if they sprout. Just make sure you're using viable seeds that aren't too old. If your compost fails these tests, you can try curing it longer, or sending it to a lab for analysis. And you can always send it to a lab just to see what nutrients are in your compost. And then the best use of finished compost is as a soil amendment. So it's going to improve the health of your soil, and you just want to mix in a 2-inch layer of compost into the top 4 to 6 inches of soil. You can also use compost as a mulch. So you'll spread a 1 to 4 inch layer of coarse compost around your flowers, shrubs, trees, and vegetables. And you want to keep it at least a foot away from tree trunks and a little bit away from stems. And it's best to use like a coarser compost as a mulch. And then you can also add compost to commercial or homemade potting mixes, and you want to have a finer compost for this. So you might want to run your compost through a screen to remove the large pieces. And here's a list of some tools you may want to purchase when starting to compost. So of course you want work gloves to protect your hands, especially when you're working with food waste, a composting thermometer to monitor your process, a scale if you want to track the amount of organic waste that you're composting and how much you're diverting from landfills, a binder to record observations during composting. It's really important to have water available, so a hose and a nozzle to bring the water to your compost pile, shovels to add material to the pile, pitchforks to turn the pile, and then have loppers or shears handy to cut up the larger materials. And then, especially when you're moving mulch, have a wheelbarrow to take mulch from your mulch pile to your compost pile. And then finally, covered buckets or bins to collect the food waste. The one on the lower right, the black and yellow bin, is what we use at Route 66 because they stack nicely for storage and transport. They hold about 17 gallons and they can be lifted by 1 or 2 people. You can purchase these at any big box hardware store. And not everybody keeps records, but it can be helpful to record the observations of your composting process so you can improve it as you go. It's also a good learning experience for students. So you're going to be using your senses to note the moisture content, the odors, pests in the pile. At Route 66, we use a log like this one from the Institute of Self-Reliance. And that will be you'll be able to find that in the resources, which I'll put in the chat at the end. Each time we work on the compost at Route 66, we record the date, the names of the volunteers who are working the compost, the moisture content, odor, temperature. We usually take it in 2 places, at the top and on the side, and when the pile was turned. So I just want to show you some pictures of composting systems I've used or seen, and these are all local. The most common method for larger scale composting is open piles. They're also called windrows when the piles are long and narrow. So the picture on the left was taken at the Route 66 community garden. And we currently have 2 composting areas. In the area here, we're creating open piles to start an urban farm. And the mulch is being provided by the city through Burtec. And we're adding food waste that we pick up from local coffee shops and a juice bar. And this large scale composting is being funded by Community Composting for Green Spaces. It's a grant through Cal Recycle. The picture in the upper right is at Puerta del Valle. It's a community garden and farm in Ontario, and they create these large windrows on a concrete base. And then the photo in the lower right is Amy's farm, also in Ontario. And they use more circular mounds, and this is finished and curing compost. And then these are some bin systems, a little bit smaller. So the picture on the left is the composting area for members at Route 66. And you can see that it has 3 bays for 3 compost piles. And each bay is 8 feet wide by 8 feet deep and about 4 feet high. And the piles stay in the same bay from start to finish because they're so large and kind of hard to move. And when the compost is done, it's moved to a pile on the right-hand side of the system, and the food scraps are collected in the buckets on the left-hand side. And you can see like one of those orange buckets there. Those are 5-gallon buckets. The 3-compartment system you see on the right is at Seeds of Joy Garden. It's in a city park in Ontario. And this system is much smaller than the one at Route 66. It's completely enclosed. In this type of system, the piles are typically moved between bays as they mature. And then I'm going to just touch briefly on vermicomposting bins. Vermicomposting uses worms as the primary decomposers. But in general, it doesn't produce enough compost for large-scale composting, but it's a great teaching tool and a good addition to a traditional compost pile. The photo on the left is at Huerta del Valle. It's the biggest vermicomposting system that I've seen. They have very large bins that they put the organic material into. The 2 pictures at the right are common smaller vermicomposting bins. The main type of worm used in vermicomposting is the red wiggler, and they're easily purchased online, and they're surface dwellers and they eat the organic waste that's added to the top. The end products of vermicomposting are the castings, which is essentially worm poop, and the liquid, also called tea, that accumulates at the bottom of the bin. And both of these can be used as natural fertilizers. So I've talked a lot about community gardens, but I wanted to share a few tips for composting at schools. The first 2 tips are about obtaining support from your school administration, your city, your community, for your composting project. This is very important for the success, because it does take resources and volunteers to make this work. And then if you are collecting food waste from the cafeteria, you want to involve your cafeteria and custodial staff, because you're going to need their help, especially with the cafeteria waste sorting. And you want to decide whether you're going to compost on-site or off-site. If you don't have a garden, you may want to partner with a local community garden or farm to compost your waste. And then educate your entire school community to make composting something that they're proud and excited to do. Again, you're going to need volunteers and help to do this. It takes more than one person. And it takes some tending on a daily or weekly basis. And then promote your composting program through activities and events. And composting can be integrated into the curriculum to teach science, math, and engineering concepts. And you may want to keep track of your food waste that you keep out of landfills so that you have measurable results. And so to end, I'll just quickly summarize the steps to start composting at a larger scale. So you want to first set your goals. What do you want to accomplish by composting? How much do you want to make? Find your team, develop a plan, select the site, choose your system depending on how much compost you need and how much you can tend it. Obtain your tools, collect and manage your materials. So especially the browns, you're going to need a good supply of mulch or wood chips to add browns to your compost. And then on an ongoing basis, you need to manage your process and your site. So the next two slides are composting resources, and I'll copy these and put them in the chat. And my favorite ones are the ones from the Institute for Local Self-Reliance. They're very detailed, well-organized, well-written. And here are some more resources. And that is the end of my presentation. Thank you for attending. Are there any questions?